bombs are much more powerful than atomic bombs. This is due to the different reactions they have. Atomic bombs like the ones used at Hiroshima and Nagasaki use fission to split atoms. The splitting of a large atom into two smaller ones triggers an explosive chain reaction. Hydrogen bombs use helium to create two more atoms into one big. The results in a hydrogen bomb being thousands of times more powerful. Hiroshima exploded with a force equal to 15,000 tons of TNT. But the TSAR bombard, the biggest and the most powerful hydrogen bomb ever tested, produced a yield of 15 That's equivalent to 3,800 Hiroshima bombs. I'm talking about the fission and the fusion nuclear reaction. First, I'm going to start my presentation with the structure of the atom. Basically, the atom contains in the middle the nucleus, which is the center of the atom, surrounded by the negative electrons, and inside the nucleus there is two things, the positive protons and the neutral neutrons. First, the nuclear fission. The nuclear fission is a reaction in which an atomic nucleus of a radioactive element split by bombarded from an external source. This means that the nucleus of a radioactive element splits into two atoms by an external force with simultaneous release of large amount of energy used for electric power generation. Means that when this nucleus splits into two other atoms, basically it releases a large amount of energy, and this energy is used for electric power generation. The reaction of the nuclear fission is called a chain reaction. So this reaction occurs when the mass of the uranium undergoes the fission reaction, releasing a large amount of heat and energy that produces atomic fusion. When this reaction happens, it releases very large amount of energy, which is in the form of heat. So the first thing, this is one nutrient starts the chain reaction, and then the nutrient split the uranium nucleus into other nucleus, and when it is split, it releases amount of energy and nutrients. This is the nuclear fission diagram. One nutrient, one is the mass of the nutrient, and 0 is the charge. Plus uranium, then it gives me two atoms, two another atoms, plus the energy, plus the 3 nutrients. This happened because the uranium is a radioactive element which is unstable. And in this equation, there's something called the mass conservation. This means that when you make 1 plus 235, it is equal to 236. And when you make 91 plus 142 plus 3 times 1, it's going to be equal to 236. Now we're going to calculate the energy from the fission. The energy from the fission reaction is equal to the energy per fission, which means that the amount of energy released by 1 kilogram of uranium. This is called uranium-235 because this is an isotope. We have uranium-235, we have uranium-236. So because we have lots of isotopes. So the energy per fission multiplied by the number of atoms, it gives you the total energy released by the fission reaction. Everything has its positive thing and its negative thing. The same as the fission. The fission has good things and evil things. The good thing is that if the chain reaction was controlled, it will give me a good thing. But if it is uncontrolled, it will give me an evil or bad thing. So the good thing, a controlled chain reaction in a reactor used in nuclear power plants to produce electricity. Basically, if the chain reaction was controlled in a reactor, we use the energy released in order to produce electricity. What about the evil thing? An uncontrolled chain reaction is used to create incredibly powerful weapons. The atomic bombs dropped on Japan, like Hiroshima, what happened in Hiroshima was because of the atomic bomb, which is a nuclear fission reaction. A nuclear fusion is the process by which multiple nuclei join together to form a heavy nucleus. Basically, the nuclear fusion is the opposite of the nuclear fission because the nuclear fission there is a neutron which splits the atom into two other nuclei. But basically, the nuclear fusion is the opposite because there is two nuclei joined together in order to form one heavy nucleus. It is accompanied by the release or the absorption of energy depending on the masses of the nuclei involved. Here's an example. Here we have deuterium. Deuterium means H2. It's an isotope of the hydrogen atom. Plus tritium, also it's a hydrogen isotope. To form helium, they form helium. He4 2. Also the same as the fission reaction, it releases the energy plus nutrients. Also here we can calculate the energy from the fusion, but the number or the constant number differs between the fusion reaction and the fission reaction. The energy released per fusion is 2.79 times 10 power negative 12 joules multiplied by the number of atoms in order to calculate the total energy. There is an atomic bomb and a hydrogen bomb. An atomic bomb, like what happened in Hiroshima, it killed over 66,000 people instantly. And it contains 13 kilotons of TNT equivalent. TNT is the unit of the energy released of any explosion. Basically, they use the atomic bomb in warfare. Hydrogen bomb is 10 megatons, million tons of TNT equivalent. It never exploded in warfare. They never used this bomb in anywhere because it's very, very powerful. Fusion has advantages and has disadvantages. The good thing is that a controlled reaction in a reactor used to produce cleaner and inexpensive electricity. We use fusion reaction right now in our Earth in order to produce electricity. The evil thing that a fission bomb starts a fusion chain reaction to create an incredibly powerful weapon. Also, they use the fusion reaction in order to create a powerful weapon. Thermonuclear weapons like the hydrogen bombs much more destructive than atomic bombs. The atomic bombs uses the fission reaction, while the hydrogen bomb uses the fusion reaction, which is much more destructive than the atomic bomb.